All right, so now we're recording. So we're going over the chapter 10 test. This is homework number 15. The first three questions are simply just asking you, A, where are these segments here? So B, that's KL, is this. That's a tangent because it's just going to touch a circle at one place. So remember, a tangent touches a circle once. Your notes say that. Secant passes through a circle. Passes through 2 points on the circle. And sorry for my poor spelling with through, but just being lazy. And external just means outside, like exterior, or internal is inside, external is outside, right? So LM is completely outside, it's not even inside the circle. LK technically is external too, but because it's touching at one point, and it's just going to touch at one point, if you extend that, that's what we call a tangent. But LM, if you were to extend that, it would touch another point on the other side. So that's what we call that an external segment. Okay, for these three, remember, if you have two tangents, they're going to be the same. If they're coming from the same point on the outside. So these are both tangents. You've been told that. Oh, you're told that for Y. What did I talk about? Y and Z. That's weird. Anyway, I'll be more explicit and clear about that in our test, that these are tangents. So yeah, those will be the same. Solve for X. This is Pythagorean theorem for number 8. Remember, if you have a tangent line, it's going to be perpendicular. So you have r squared plus 12 squared equals 6 plus r squared. If we work that out, r squares cancel, r squares cancel. And you do have to FOIL this. So you have to do 6 plus r times 6 plus r. So definitely whoever in the group seems more confident in their algebra skills, maybe designate that person to kind of check the algebra, make sure the algebra is done correctly. And the r squares cancel. Move the 3060 to the side, solve for r, not that hard. And 9, again, Pythagorean theorem again, you have 9 squared plus r squared equals 3 plus r squared. Work it out, you got r. Not that hard. Okay, here. So if you know that's 100, then that's 100. If you know that's 120, that's 120. This part's not terribly obvious, but that's all going through the diameter. Sorry, that makes no sense. LN's going through the center. LN's a diameter. So that's 100. That's 80. I'm in class right now. Yeah. So that's the diameter, right? So that's 100. That's 80. Therefore, that's 80. Remember, these have to add up to 180, right? Because it forms a line. So if you have 100, that's 80. And then that's 120, so that has to be 60. Because that's another, again, here's your diameter, that has to have to 180. So now we're golden, right? Because now we got, oh yeah, that's 80, that's 60. Now I can just figure out the rest of this, right? So KL, that's 100. NML, 180. LM, 60. NLM, so you gotta go that direction. That's going to be 240. KM, you always go the shortest possible distance. If you could go major or minor, usually go with the shorter possible distance. So 160. MN, 120. KN, 80. KLM, 160. There we go. Find the measure of the arc measure of AB. Okay, well, here's the deal. You know that these are the same because those were already marked up. So these arcs are the same. That's another rule that we have, is that if you have two congruent arcs, two congruent chords, the arcs they intercept are going to be identical as well. So, and C is obviously a center. So that's 61 degrees. So that's 61 degrees. And because these are the same, that's 61 degrees. So that's 61 degrees. That's why you get 61 for arc AB. Here again, you got two congruent chords. So you have two congruent arcs. If that's 65, that's 65. Again, you got two congruent segments that are perpendicular to these chords. If that happens, it means that both these chords are the same. AB, segment AB, is going to be congruent to segment ED. Because you have these perpendicular segments that are equal to each other, right? So if that's 91, that's 91. There you go. These are using more intense formulas. So this is why the reference sheet is going to be really your best friend for tomorrow. So I'm going to go pull it up again. Nope, wrong one. Boom, here we go. So see, you got all this stuff here. So have this out. That should be out for sure. I'll print it for you guys. How about that? I'll print it, but make sure it's you're using it, right? You don't, it's not there for nothing. So yeah, so anyway, half of 56, you get 28. 40 is half of x is 80. Q plus 80 adds up to 180. 4r plus 100 adds up to 180. You get those values there. Not that hard. Pretty easy, right? Questions on those so far? And again, like you just use a reference sheet, like you see this situation here, right? You see an angle inside, just use a reference sheet. And there you go, x is half of n. Just draw that connection. You shouldn't miss these problems. These are gimmies. Or if you see this kind of situation, okay, like I have, these add up to 180. I don't know if that's on the reference sheet. Okay, actually that's not on the reference sheet. So, okay, well, your notes should have it. But I know this is on the reference sheet. If that's 250, then this is 110, this portion right here. I know that's in the reference sheet. If you have two tangents, axis angle is half of m minus n. That's exactly what I did here. Half of 250 minus 110, you get 70. It looks like it's 70 degrees, right? I know we don't go based off looks, but yeah, looks like it. X is the arc here. So 40 is half of 96 minus x. Again, that's something else. We have a reference sheet on that, right? X is half of m minus n. Here, if you have two chords, and then you have these two arcs, you're going to average those. You're going to average those two. So it says so right here. You have this kind of scenario, half m plus n equals x. There you go. Not that hard. This right here, remember we talked about when you have two chords that intersect. If you take the portions of each chord and multiply them out, x times 8 equals 14 times 4. Not that hard. Pretty easy. Equations of circles we've talked about. Should be pretty straightforward. I don't think we should be missing these problems unless you make some careless mistake or you confuse the minuses and the pluses. The equation of circle, I think I have right here. I don't. Okay. I think I'll handwrite some of these before I photocopy this. We'll handwrite some stuff on here. Yeah, because I think that would help you guys. Yeah, just drawing circles. And then this is just one more kind of chord arc situation. JG is going to be 86. So GHJ, all this right here is 360 minus 86, which is 274. So it'd be 274. Okay. Hopefully we're A-okay off of all that. Any questions? If you felt you did fine with this and you breezed through it last night, like, yeah, I've got this, you got chapter 10 down cool. You're gonna be fine for the test for this chapter 10 part. And I think chapter 11 is easier. chapter 11 is just a lot of just area stuff and just plug and chug. Okay, so let me leave these up because I think this will still be helpful. Maybe I could close this down for now. I'll close this down. Okay, so we're going to talk about 11.4 now. And then after we finish 11.4, I'll kind of point you to some of the 11.4 type problems on here, just to kind of just knock it out, get out of the way. And then we'll do a break. Okay, so let's talk about 11.4. And let me kind of just quickly take a peek here of what we're dealing with. Okay. Okay. Looks like it's all arc length. That's area and sectors. Got it. Okay. So 11.4. I'm not sure if there's a title next to it. Circumference and arc length. Okay, that is the title of it. Okay. So 11.4, circumference and arc length. Great. Well, here's the deal. Let me actually share a whiteboard instead. Okay. So circumference is this, 2 pi r. And pi is roughly 3.14. So for example, let's say you have like a circular track. Okay, that's a terrible looking circle. So you have a circular track and so you walk around it. So you got a person here. Okay, that's an ugly looking person, really long neck, but they're walking around the track, right? You know, some of you guys might have like a wearable device that tracks your steps, or maybe your cell phone does it. Some places have something called a Fitbit, and you know, it just tracks, you know, the distance you walk, right? Well, if you're walking around a track, if you want to find the distance you walked around the track, obviously it's not linear, it's curved. You know, it depends on the radius of the track, right? Let's say the radius of the track is 50 feet. Actually, tracks are usually bigger than that. We'll say it's 200 feet. So your circumference, the distance you walk around the track, would be 2 times 3.14 times 200. And what's that? Let me get a calculator here. So that'd be 1,256 feet. So if you walked around a track that had a radius of 200 feet, walked around it once, that's how much you walked. They do say that it's going to get about 10,000 steps a day, which is roughly about 5 miles. For those who are not sure, there's 5,280 feet in a mile. So you'd have to walk around this track probably 4.5 times to get to 1 mile. And if you want to walk 5 miles, then you have to walk around this track probably about 20 to 30 times. You know, for those who are runners, maybe, I don't know if you run around the track that many times, but yeah, I mean, if you want to get 5 miles in, you'd run around the track about 20 to 30 times. You'd be pretty exhausted, especially in the heat. But those who want to take a nice stroll around the track, sometimes they'll do it a few times to get some of their steps there. So, but that's what all circumference ever is. It's just distance around a circle. Now, arc length is a portion of a circle. Anita, go ahead.
I'm sorry, can you go back?
No problem. The part you really want to focus on is just this right here. This is the most important part. And then that pi is 3.14. This is just more for fun, the other stuff, and that's just an example here. And that's not really necessary. You don't need to know that. That's just if you're curious how much you're walking in terms of miles.
Thank you.
Yeah, no problem. Okay. Now, arc length. Arc length is simply a portion of a circle. That's all. Just a portion of a circle. So let me actually draw a nice circle. Let me draw the center. Let me draw a radius. Let me draw another radius. Actually, let me do this. And I'll get a highlighter out. And let me label. Call this A and B. I'll call this C. Say angle ACB is 90 degrees. Okay. So that's a right angle. And say the radius is 2. So it means that's 2 and that's 2, right? So the question is, what is the length of arc AB? And remember, circumference is 2 pi r. If anyone can give me the answer, first one to give me the answer, if you put in the chat, I will give you extra credit, a point of extra credit for our test. Actually, with that, I'll give you 2 points extra credit towards our test tomorrow. So if anyone can work this out, tell me what the measure of the length of AB is. You know circumference. You know it's 90 degrees. I've not given you the formula for arc length yet. I've not given you the formula for arc length. And I don't want to, because you got to think logically. I don't want you getting too reliant on formulas. I want you to think here. What do you think the length of the arc AB is going to be? Use some intuition. And just type in the chat if you think you got it. And if you're wrong, that's fine. You're not going to lose points. Doesn't hurt to try. Or if you want to speak in your microphone, if you think you know it. What do you guys think the circumference is? You have the formula, you have the radius. Okay, cool. We got a brave soul. It's not 25.12. That would be actually too much. It's not 12.56. That's the circumference actually. The circumference is 12.56. So that's good. The whole thing, the whole circle. Okay, so you're on the right track. The whole circle, or the circumference, is 12.56, which is 2 pi times 2, which is 4 pi, which is 4 times 3.14, which of course is 12.56. That's the whole circle. But what about the green? What would the green be? But you guys are getting there. Well, 180 when it makes sense. That's maybe you think of an angle. Remember, this is 90 degrees, right? That's 90 degrees. So that's 90 degrees. How many degrees is the whole circle, guys? If we remember the whole circle, how many degrees is that? 360, right? So the whole circle is 12.56, but this is only 90. What fraction is being shaded here? Think of that. Not 28.6, that's too large. So think about it. If the whole circle is 12.56, the length of the arc is definitely less than 12.56. So that'd be physically impossible for the green to be more than 12.56. It's got to be less than 12.56. Right? You're only doing a portion of the circle. 6.3, getting warmer. But remember, we want to make sure that we're looking at the right portion. Bingo, got it. Good work, Ellie. 3.14. The answer is 3.14. Excellent. Thank you, Ellie. I'll make sure you get some. And you know, I know I still owe you extra credit, so don't worry. I'll update your grade. I know Neil's got 2 points from previous opportunities. So yeah. So why is it? Let me erase some of my stuff here because now this is getting a little busy. So why is it 3.14? Let me erase. All that. So remember, a full circle is 360, right? A full circle is 360. But you only have 90 shaded, right? Because that's 90 degrees, that's 90 degrees. What's 90 over 360 reduced to? 1/4. 1/4 of the circle is shaded. And the circumference is 12.56. If you calculate it, right? So all you do is you do 12.56 divided by 4. That's all. That's all you do. It's just a fraction. That's all it is. It's proportional reasoning. And that's a reasoning skill that I think you guys still need a little more time to develop, that probably hasn't been developed enough in you guys. And that's gonna be the theme of today. I'm gonna develop in you guys today. Just look at what fraction is shaded, multiply that fraction by the whole thing. That's all. That's all we're doing. So now let's talk about the problems.
Thank you.
Okay. So first off, let's find circumference. So that'll be 16 pi feet. Here the radius is 6.5 because they give you the whole diameter. So we have 13 pi inches. And ooh, that's a weird number. That's 131.96 pi centimeters. And notice I left the answers in terms of pi. I didn't multiply the pi out. It's kind of up to you. It's kind of a preference thing. Some people don't like to multiply the pi out because they don't want to deal with decimals. If I did multiply the pi out, then I would have 16 times 3.14. if you want to find like, the real number of feet going on here, that'd be 50.24 feet. And you could, it's up to you. But if it's a multiple choice question and the answer is in terms of pi, then you don't multiply the pi out, right? So that's what's going on there. So circumference is 2 pi r, or pi d, because diameter is twice r. So you could replace the 2r with d, that same thing, and that could have done that for number 2 also, because d was 13. Or for number 1, I could have doubled the radius and then just pi d, 16 pi. So that's circumference again. We've already talked about that. Now let's talk about arc length. So you have to find the measure of arc AB. So if you think about it, you have 150 degrees for the central angle, meaning the arc is also 150. The whole circle is 360 degrees. So you need to figure out what fraction is shaded. And you multiply it to the circumference. So it's 2 pi times 18. And that's 150 over 360, so that's 15 over 36. Each of those are divisible by 3, so that's 5/12. Those cancel. You get 15 pi. Now, is there a formula? Yes. I'll show it to you. I'm kind of begrudgingly showing it to you, but there is a formula, and it's just this. It's the angle. So theta, that's your central angle. The central angle that intercepts the arc. Divided by 360, because you want the fraction that's shaded, and multiply by the whole thing. And 2 pi r is the circumference. So this is purely proportional reasoning, because what you're doing is like, if you take your arc length and divide by the circumference, it's going to be the same thing as the central angle divided by 360 degrees, right? Like, for example, 15 pi is my arc length, my circumference is 36 pi, my central angle is 150, 360 is a whole circle. They're going to be the same thing. They're the same exact thing, as it should be. It's all proportional reasoning. So that's what's going on with number 4. So number 5 will be very similar. Here, I think the diameter is 28. Because whenever you put it right by the center, I think that's a diameter. Whenever you put it closer to the edge, I think that's a radius. I'll be more explicit on our assessment. So let me do number 5 down here, because I think I'm still copying. So our radius is, of course, 14. So if I do, and you want arc AB, right? Arc AB. So the central angle is 30 degrees. And then just times 2 pi times 14. Work it out. 30 over 360, I believe, is 112. And then you do 28 divided by 12. I think each of those divisible by 4. So you say 7 pi over 3 feet. That's it. There we go. Hopefully we're okay with that. Oh. Okay, hold on one sec. Okay, guys. Oh. All right, sorry about that. The water is completely shut off in this building, and the bathroom's not working. And so there was supposed to be a math classroom in here for us, some summer class, and but it got moved to another building, and kids are coming to this room, not knowing that. So anyway, all's good. I don't need to move. So yeah, for number 5, it's 7 pi over 3 feet. You could compute if you wanted to, like compute the pi and yeah, it would be like 7.33 feet. If you actually want to multiply the pi out. Up to you. Or you can leave it like this, 7 pi over 3 feet. So that's arc length. There is a formula, but if you just think about it in terms of proportional reasoning, it's not that hard. Just take the central angle, divide by 360 to get the fraction we're dealing with, and just multiply it to the circumference. That's all it ever is. So here, angle EDF is the same as angle FDG. Okay, then that's 80 degrees also. So the measure of arc EFG is 160 degrees. So when they ask for the measure, they're asking for the angle, but then the length of EFG, well, actually they're asking for the length of EHG. So if that's 160, then that's 200 degrees. And they're asking for the length of EHG, so you do 200 degrees over 360 degrees times 2 pi times 7, because it raised to 7. And you can just work that on the calculator. I'll multiply the pi out. So it's 24.43 meters. So that's that one. For EHF, now this is going to be 80 right here. So for EHF, all that, that's going to be 280 degrees. Over 360, okay? That's 280 over 360. Those cancel 28 over 36. But before I do that, so I'm getting ahead of myself, sorry. EHF, that's just 280 degrees. I was actually doing number 9 for you guys, sorry. Actually, I don't know what I was doing. Just 280 degrees, EHF. So let me erase this. It's getting a little too busy. My apologies. Had a mental lapse there. EHF. Remember, this portion was 200. And that was 80. So you get 280. Now, FEG, if you want to find that length, so that's 80. So that's also 280. Okay, interesting. It's also 280. times 2 pi r, 2 pi times 7. 20 over 36, that's 14 over 18 times 14 pi. That also reduces to 7/9. Multiply out the pi, you should get 34.21 meters. Okay. Give you guys a chance to copy that down. Okay, let's keep moving. Last problem here, then we'll do some practice and we'll do a break. Find the perimeter of the mini hockey rink. Interesting, okay. So that's 11. That's 11. That's 41. And that's 41. However, you got a curved part. And these each 90 degrees. To 90 over 360. And now it's not obvious what the radius is, but 11 covers 2 radii. So it means the radius is going to be 5.5. Because you have 11 here, covers this, right? So it covers the radius twice. So 2r equals 11. So r is 5.5. So you're going to do this to get that arc. If you work it out correctly, you get 8.64. Okay, 8.64 inches. Okay, you have 8.64 inches. And you got to multiply that by 4. Because you got 4 arcs. So it becomes 34.55. And they add on the 41, 41, 11, and 11. Because those are the straight sides. So you should get 138.56 inches. So that's how you find the perimeter of that ring. So it's a little more advanced, but you got an arc, you know, that's 90 degrees. So that's 1/4 of a circle. You know, circumference you can figure out because you know the radius is 5.5. As I showed you, that 11 covers both radii. So r is 5.5. Work out the arc length. But if 4 arcs like that, so I multiply by 4. And then you got 4 straight sides, 41, 41, 11, 11. There you go. Yeah, and they put we didn't have the answer for 10, but anyway. So any questions? We're gonna do just a few practice problems before we do a break. Okay. We're A-okay.
So let's do the Chapter 11 test review. You guys should have that should be the last couple pages of the Chapter 11 packet. Now let's take a look at numbers 15, 16, 17. So this is a Chapter 11 test review, and we're looking at 14, 15, sorry, 15, 16, 17. So that's from 11.4. Okay. So circumference is 94.24. So that equals to, you have to find the diameter. So you can set equal to pi d or 2 pi r, same thing. You get 30.01. Okay. Next one. This is a little more advanced. Circumference is 2 pi r. Arc length is 5.5, 35 degrees. Remember, that's the formula, right? Arc length. And that right there is the circumference. So I probably don't even need to write 2 pi r. I can just call it capital C and solve for capital C. So you can divide by that fraction. So that whole fraction goes below 5.5. And you should get 56.57. Could also have done this too. I could also have done 5.5 over the circumference equals 35 over 360. That could have been fine too. Because all proportional reason, right? You're doing the arc to the circumference, the central angle to 360. That could have worked too. You just solve for C. So 5.5 times 360 divided by 35. Yep, you get the same thing. 56.57. So that's 16. So GH. You want to find that arc? You do 115 over 360. Two pi times 13. So 115 over 360 is kind of a wacko decimal. You get 26.08. That's all. So, and we could check the answer really fast, which is right there. They had 26.09, whatever. I think I ran a little too soon, or maybe around too soon. I don't know, but yeah, that's all it's going with 11.4. So it's a very, very basic topic. Circumference 2 pi r. Arc length is just take the central angle, divide by 360, and multiply to the circumference. Or figure out what fraction you're dealing with, which is determined by the central angle divided by 360, right? Times 2 pi r. Okay, so it's 10:13 right now. Let's take a little break. When we come back from the break, we'll talk about area of a circle, which is pi r squared, because you're doing square units with area. We talk about square footage in a house, circle, same thing. But, pi r squared is the area for a circle. And we'll talk about the area of a sector, kind of like a piece of pie or a slice of pizza, right? Like, what is the area of that piece? Not the arc length, but the area of the piece. So it's going to be kind of the same thinking, same logic. So we'll go through that. And definitely we'll do some practice problems that deal with that stuff. Then we'll talk 11.6, which is area of polygons. There's a kind of general formula for that. Not too many problems there. We'll look at those problems from the test review. And actually, we're not doing, I really love 11.7. That's a really good, we're gonna have to forego. Maybe I'll put as extra credit, maybe. It's really good stuff. I really like those problems, but yeah, we'll come back from the break in 15 minutes. So at 10:30, let's be back. And we'll wrap up chapter 11. And then we'll have a lunch break at 11:30, and we'll come back from the lunch break and we'll do more of the chapter 11 test review, and also have your groups figured out by then too. All right, so let's take a break right now. You guys can stay on or leave and come back. Let me pause them. All right, so let's talk about 11.5. Let me share my screen. All right, so this one's about area. And again, let me go to a whiteboard again to help you guys understand 11.5 a little better. So area of a circle is simply this, pi r squared. That's all. So say you have a circular lawn. Actually, before we did a huge construction project at my current school, right outside my classroom, we had a circular lawn, which we converted to a garden, which then we got rid of and did a whole bunch of crazy stuff. But this is important because what if we wanted to resod that lawn, right? Like, what if we want to, if grass got short, we just want to just update it, and we wanted to buy a bunch of sod from, let's say, Home Depot or somewhere else. We have to make sure we order enough, right? And usually, you order by the square feet, right? So, and of course, you're not going to order it in a circular fashion. They usually come out in long rectangular strips. Or we buy enough strips, then we cut off, and have it nice and circular, right? So that would be kind of practical, actually. I don't remember the radius of, I think it was like 100 feet, if I'm not mistaken. So if I want to find that area, I would just do this. Actually, what I think about it, I think it was much smaller than that. I think it was like 50 feet. So we'll do 50 instead. So if you work that out, it's going to be 3.14 times 2,500. And I use my calculator. So it comes out to about 7,850 square feet. Which actually is about the size of maybe someone's lot in their house. I still think it's a little, I don't think it was that big, but yeah, we have to make sure we order enough grass or sod to fill up a circular lawn, if that's what we're talking about. But just a circle in general, there you go. Just plug in the radius into that formula, you get the answer. Not that hard.
Very, very simple. But what if maybe there's only a certain portion we want to decide, right? Like what if like a certain portion, like maybe the sprinklers didn't work in that portion, or maybe you know, a certain tree right next to it, you know, grew like crazy and covered that part of it, and that part wasn't getting enough sun. And that side's all brown now. We need to just replace that part. We don't replace all the grass, just maybe that portion of it. So let's go back to what we already talked about before. What if I had 90 degrees right here, and say that we're 50 and 50. But now I want to find the area of all this. So we call this a sector. Remember we did arc length in the previous section? But this is a sector. Sector is kind of like a piece of pie. Or a slice of pizza. Think of it like that. And so I want to find that area. With the area of the shaded region, okay? So what do? You do 90 over 360 times the area. That's all. That's all you do. Just like we did before. You do the same exact thing. So it'll be 1/4. But instead of circumference, we're using area. Same thing. So it'll be 1/4 of pi of pi, which is 3.14, of course. So what's that going to be? So you get about 1,962.5 square feet. So that's the story of that one. So the formula will be this. Theta over 360 degrees area of a sector. So sector is a section of a circle. Think of it like that. That makes sense. Okay. That's all. That's all that's going on with that. Area of a sector. Theta over 360 times pi r squared. You just want the area of the shaded region. So it just depends on the angle that we're told, right? And that dictates what fraction of the circle is shaded. It's that simple. Okay, let me leave this up. Some of you guys might still be copying. Oh, right. Okay. Let's go sharing the white, this right here. So again, you're just asked to find the area. And then here you're asked to find the radius for a given area. And then we're doing sectors for 6, 7, 8, 9. The 10 by word problem. So we'll work through that. And then we'll move on to 11.6 after that. maybe we do these, but I think I might want to hold off and have you guys practice these skills in a breakout session. So let's talk about this. Area pi r squared. R is 6. So 3.14 times 6 squared. 3.14 times 36. You get 113.04. And square inches, right? Now here, R is 12.4. It's half of the diameter, right? That's the diameter. So 12.4. Area wherever that is, 12.4 squared, 153.76. 153.76. And that's it. 482.81 square centimeters. Hopefully we're okay at that. No questions? Okay, I'll leave this up. Let's take a look at number 3. If the area is 154, you want to solve for the radius. And likewise for number 4, it's repetitive, 380 equals pi r squared. But first, let's do number 3. R squared will equal 150 over pi, or 150 over 3.14. So R squared, whatever that is, that's 47.77. Square root both sides, which is 6.91. 6.91 meters. So go and try the same for number 4. I'll give you guys a moment to work that out. It's the same exact thing. But remember, we had a square root to get rid of the square next to the R, and then that will get us the answer. So I'll give you guys a moment. And also try number 5 as well. We can still see number 5 here. So you're going to say 676 pi equals pi r squared. By the way, the pi's will cancel from each side. I'll let you guys work that out. So go and work out 4 and 5. And then we'll move on to the other parts.
Okay, for number 4. You have 380 over pi. So r squared will equal whatever that is. 120.96. R will be root 120.96. If I square root that, I should get 10.998, or roughly 11 inches. Okay. And then for number 5, let's change colors. Root 676 equals r. R will be 26. So the diameter will be 52 centimeters. That's all. So it's 3, 4, 5. And 1 and 2, we already did. Any questions before we do the other 5 problems? Nope. Okay. We shall keep moving. Now, arc length. Remember, you take the central angle, divide by 360, and multiply by pi r squared. You can do likewise over here. It's not that hard. It's very, very straightforward. Very straightforward. And just punch in your calculator, see what the calculator says. Okay. Before we get too carried away, just remember there's a reference sheet. Hold on 1 sec. All right, sorry about that. Just had a student drop by for a practice test. But you can see the forms right here on the Chapter 11 reference sheet. Part to whole. So arc length over 2 pi r, 2 pi r being circumference, is measure the arc over 360, or measure the central angle, think of it that way, or area of the sector divided by pi r squared. Just these are really just theta, and theta is just right here. So you have the reference sheet, it's there anyway. And let's work these out in the calculator. Yeah, should get about 9.07 inches here.
And the other one, you get 827.02 centimeters here. And sorry, these are squared units. My apologies. Those are all squared units. Okay, hopefully you guys are okay with that. We'll work backwards for 8 and 9. Okay, we'll go and clear. For 8 and 9, so now you're given the area of the sector, and you're given the angle that's in the center. And you gotta solve for the area of the whole circle. Well, this is the area of the whole circle. I mean, you could put pi r squared if you wanted to and solve for r, but we're solving for the area anyway, so you might as well just kind of combine and call it the whole area. And likewise here. 40.62 equals 98 degrees. Times area. And again, just using your calculator. It's not that hard. Actually, let me pull up my calculator so you guys can see what I'm doing. Yeah, so for the first one, 23.79 divided by, and then in parentheses, 8/360. And that's that, 107.06. I don't know the units for that. I'll worry about that later. And for the other one, you just do 40.62 divided by 98/360. And that's that. You get 149.22. And that's gonna be square feet in square inches. So, and of course, the area of the circle is bigger because the sector is a smaller part of it, right? So that's 8 and 9. Okay. Fine, let's look at number 10. So what is the area of the lawn that is covered by the sprinkler? Okay. Well, 135 degrees, 360 degrees times pi r squared. You know, because the radius of the sprinkler is 16 feet. And that's also good to know too, because sometimes you want to make sure, like I'm having that issue with my front lawn, like one of the sprinklers not really covering it, so I'm gonna have to figure out how to fix that. Maybe I buy one of those portable ones and just, I don't know, run it early in the morning or late at night. Because my automatic sprinklers are not covering a certain part. But yeah, that's important, right? You know, it's kind of a practical problem. So yeah.
So just work that out. So we have this much lawn covered. Square feet. But what if the water pressure is weakened and only 10 feet's the radius? So that's 10 feet, right? So now it's not covering as much of an area. It's covering less grass. So you do the same calculation, replace R with 10. And you see significantly less is covered. Much, much less. So yeah, that's all. Again, pretty straightforward, but I just want to make sure we kind of took our time, didn't rush through this. Okay, hopefully we're A-okay with all this. Okay, cool. Okay, we're going to move on to the last topic. So I won't do the 11.5 problems from the test review. I'll have you guys get in your groups when we come back from lunch. But we're still going to do one more thing before we have lunch break. Yeah, areas, circles, and sectors. You can see there's a bunch of problems. Some are kind of tough, but a good problem. So we'll definitely talk, we'll have you guys do that in your groups. So last topic. 11.6. Give me 1 sec here. Okay. So let me go back to a whiteboard again. Oh. Okay. Say you got a hexagon. So here's a hexagon. You want the area of it. What we could do is chop this up into 6 triangles. Okay. And if you think about it, that's 360 degrees all the way around. So each angle will equal 60 degrees because you're doing 360 divided by 6, right? So what this means is that that's 60 degrees, 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 that's 60 degrees. So 360 all the way around. Okay, 60, 60, 60, 60, 66, and so forth. So each of those angles are 60 degrees. Let's focus on one of those triangles. So I focus on this one right here. So that's 60 degrees. Actually, let me come around the other way. There we go. That's 60 degrees. Well, also, what do we know? Those are the same, right? It's kind of like a radius. Those are the same. So these angles are also the same. Well, you got 120 left for these two purple angles, and they got to be split equally because they're opposite congruent sides. So these are also 60 degrees. Okay, now we're on to something. So I got myself an equilateral triangle. Where that's 60, that's 60, and that's 60. And I could actually break it up like this. Now I can call this S. And of course, this would be S and this would be S. And that's just the length of the side. In fact, actually, I'll call all sides of the hexagon S. Well, if we break this down even further, you can make a right triangle, right? Here you got a right triangle. That's S over 2. That's S. This will be S root 3 over 2. And that's using the 30, 60, 90 ratios, or if you did Pythagorean theorem. So if S root 3 over 2, well, the area of the triangle is 1/2 times base times height. The base, if I focus on this right here, is S. The height is S root 3 over 2. So get S squared root 3 over 4. And I got 6 of those triangles, right? I got 6 of them. So the area of the hexagon will be 6 times S squared root 3 over 4. Now that's a lot of work to do. Because what if I gave you an octagon, or a decagon, or a pentagon, or a nonagon, or heptagon, like all these different types? I don't think you want to keep going through this process. And in fact, actually, you probably have to use some advanced trig to get the height of these triangles, right? I mean, fortunately, this is 30, 60, 90. I know those ratios, so I was able to use that. So this is a little bit advanced, right? But there is a formula we can use. And the formula is this. Area of any polygon with n sides will be this. Will be 1/2 times A times N times S. A is going to be, it's kind of a weird thing. Let me erase some of the stuff here because it's getting a little busy. So this is S. This is A. A stands for something called the apothem. It's kind of like height in a way. So A stands for something called the apothem, N's the number of sides, and S is the length of one side. Or the perimeter. If you find the perimeter of the hexagon, which is N times S, and multiply by 1/2 times A, that'll get you the area of the polygon. And the reason why that works is because it's making actually triangles for you. Because remember, the side was the base, right? This is the height. Area of triangles 1/2 times base times height. And N's number of triangles you're gonna have, right? Because number of sides. So really that's all you're doing. The tricky part is finding the apothem though. That's not gonna be as intuitive. Maybe this, I'll just kind of just give you the apothem, say here it is, and then yeah, just plug away. But yeah, that's what we have to do. So we're going to do some practice problems just a little bit. But if you guys are still copying stuff down, feel free to do so. And again, I want you guys understand where it comes from. I didn't want to just say, oh, here's the formula, just do it. You know, I want to kind of give you a sample problem. So like for the hexagon, S was the base, and S root 3 over 2 is the height, or the apothem. And of course, you have 6 triangles, 6 sides. And there's also 1/2 as well that we incorporate into our answer. So now let's do some problems. So find the area. Here we have a hexagon. Remember we said that's 8. That's gonna be 4. That's because this is 30 degrees right here. And that's 60 degrees. So that's 4 root 3. So 1/2 times your apothem times n times s. And you are forming equilateral triangles with a hexagon. So it's 1/2 times your apothem times number of sides is 6 times 8. And you just work it out. That's all. Now here we have a pentagon. I'll give the answer for number 1 in just a sec. But here we have a pentagon. So 1/2 times A times N times S. So we have 5 sides. Length through these sides 20. The apothem is not as obvious. Now, the one thing that's good to know is that that's 72 degrees. That's 72 degrees. 72, 72, 72. 72 all the way around. Sorry, 3/6 all the way around, so each one's 72. Okay, 72 all the way around. Sorry, I don't want to say that. 3/6 all the way around, each one's 72. So it means that that's 36 degrees. Which means that's 54 degrees. So the apothem, which is this right here, if I were to draw a right triangle, that's gonna be 10 now. That's 54 degrees. The apothem, in order to get that, is we have to say tangent of 54 degrees A over 10. And then you have to work that out. So it does require a little bit of extra work and using some previous skills. So it's 13.76. So divided by 2 times 5 times 20, you get 688.19. Yeah, that's it. And coming back to this one again, 0.5 times 4 times root 3 times 48. You get 166.28. Term 1. close enough. So, but you had to do a little bit of trig to get the apthem for number 2. So it's a little bit more involved. You guys are totally capable of doing it. It's definitely a more involved problem. I'm guessing I'll probably just put maybe just one problem, or maybe I won't. Maybe I'll just kind of just give you the apthem. I don't know. Let me think about how I'm gonna do this problem. Maybe I'll just do a hexagon. Hexagons are easier. So I'll leave this up because I know some guys are probably still copying. Okay. Some more here. How many sides? It's got 7 sides. So 1/2 times A times 7 times that. So I don't know this length of each side. Here's an octagon. Actually, I do know the apthem. I do know the number of sides, and I do know the length of each side. So that was actually pretty nice. But yeah, I don't know the length of the side, and I don't know the apthem here. Well, for number 4, that's going to be pretty easy. That's just 1/2. If you work it out, what do you get? You get 108. That's pretty easy. This one, you're going to have to do some trig. That's A. That's S/2. And that's 5. Make that a little neater. That's a 5. That's S/2. And you're going to do 3/6 divided by 7, which is really nasty. Just 51.43 degrees. So you're going to say then sine of 51.43 degrees. Oh, but then shoot, that's I messed up. Let's back up a little bit. That's gonna be all that. It's 51.43. So you got to divide that by 2. Lovely. 25.71 degrees. So we had to split that in 2 because that's for each of the 7 triangles. The vertex angle is 51.43 degrees, but they got split in 2. So then you got to do the sine of 25.71 degrees equals s over 2 divided by 5. If you solve for s correctly, you get 1.08. I think that's right. Hold on. Nope. 4.34. And then to get the apothem, you have to do tangent, sorry, cosine at 25.71 degrees equals a over 5. You should get 4.51. Now we can actually work this out. $68.43. Okay. Yeah, that one's kind of a doozy. I won't give you one like that. Maybe number 4 might be better. Let me make sure I got the, yeah, oof, okay, I got the right answer there. That was a little crazy. Questions on that one? I mean, it does require some, using your trig skills and your area of a triangle and stuff like that. And then lastly, you have a 1/2 times a times n times side 1/2 times a times n times sides. Clearly n is 5 here. Clearly n is looks like 9. Yep. 9 sides. Your apothem we already know is 2.5. The side length here we already know is 6. So you got to solve for the side length for number 5. Here you got to solve for the apothem. 5 sides. Let's be size 6. So we're gonna do some trig, obviously. That's 2.5. And I'll just call this like A. And this right here, you're gonna do 1/2 of 360 over 9. Because you have 9 sides, right? And if you go around the circle, that's 360 all the way around. That's 40 degrees, but then you got to split it. So it's 20 degrees. So you're gonna say tangent of 20 degrees equals a over 2.5. And there's not really one surefire formula. You have to kind of just take the situation as it comes to you. So if I solve for the apothem, that's gonna be 0.91. Sorry, not the apothem, just for A. So side length is double that, 1.82. Okay. Then here, that's gonna be 3 because it's half the side length, and that we'll call this A here. And remember, we went all the way around, that was 72. But you gotta split it. So that's 36 degrees right there. So tangent of 36 degrees equals 3 over A. Or you can do 54 and do A over 3. It's up to you. If you solve for that apothem, you get 4.13. And just work each of those out. That's all. 20.475 for this one. And this one here, 61.95. Yeah, so I know I said diameter for number 5. That's weird. These are all area problems. So just said area for number 5 is 20.5. It's pretty, yeah, it's not circle. Somebody says that. Yeah, so anyway, these are pretty wild problems. Yeah, I'm debating whether I really want to do something that complex. I felt through this pretty complex because you had to find both apothem and the side length. For 5 and 6, you're given either apothem or side length. Maybe I'll just stick with a hexagon. If apothem or side length is not given, or maybe I just kind of just give you both apothem and side length. You just plug into for like number 4. So I'll keep it pretty simple, but I want to show how these work out. So that's that one. I'll leave this up so I know some guys are probably still copying. Okay,
So the problems that deal with that stuff are over here. I think that's kind of a good one because you're kind of given the apothem. I think that's kind of fair. I don't know. You have to find the apothem. I don't know. We'll help you guys work those. So it's almost 11:30. I did promise a lunch break around this time. So let's do that right now. When we come back from lunch, actually, do you have your groups all figured out? I just wrote them down on a little post-it note here. I'll disclose those groups when we come back from lunch. Let's come back at 12:10. I think 12:10 is good. So let's come back at 12:10. So 40-minute lunch break, come back at 12:10, and we'll go to about 12:45, I'd say. That's kind of a good good time to come back. And yeah, that's what we'll do. So let me go and stop the recording.